everyone. Thanks for coming out today. I'm Michelle, and I, like Alex said, am from about 12 blocks down Telegraph, or down Broadway. So if you ever are into Chinese food or Korean food, I have recommendations. I work at Stripe, and we do payment stuff. This is not Stripe, but it's a place right across the street from Stripe because we take security really seriously, and we don't want to show you our office. At Stripe, I'm currently working on a rewrite of our user-facing payments dashboard with Alex, actually. As for everyone else at Stripe, sometimes they'll need to write CSS, usually for our existing user-facing payments dashboard, so it takes up a pretty big chunk of our code base. For some people, this CSS writing is not by choice, but because they need to ship some feature they're working on, and adding that last bit of CSS or that button to the dashboard is the final blocker before they can, write their blog post, send that email that they ship something. Or people work on CSS because they're on call and something broke, so they need to fix a bug. So it's definitely not on the top of everyone's mind, and it's definitely not the most pleasant task for people to be working on. So in working on the rewrite of the new user dashboard, I'm trying to solve some of these issues. When we first built our current existing dashboard, we created a handful of reusable backbone views. These had the honor of having their own CSS for each template. Everything else was essentially custom per template. Things that weren't obviously JavaScript components did not get considered for any sort of CSS reusability. As an example, this modal component, complete with its own fancy lightbox JavaScript, had its own template and its own CSS, and it was really special. But this modal explanation inside this modal is just styled specifically for this template that it appears in. So it just has a few lines and create new account view.css. And it worked for us at the time, but as we began having more modals that needed explanation, we just kept repeating that style over and over again in the individual templates. And we had a bunch of files just like this, where it was easy to style each individual view separately, especially because we had Sass to help us, and Sass allowed us to nest our selectors infinitely. So we could go crazy and style away without worrying about affecting other templates, except sometimes, right? Because they might be used inside other templates, or they might be reused in other contexts. Sometimes a particular template styling might be used in two places or nested in a different template that is styled and not affect it. Either way, by looking at the file names and the folder structure, there's no good way to tell because there's no convention about which views are reusable, which views aren't reusable, and there's no easy way to tell which side effects the CSS you're writing will have. So let me take you into a couple minutes in the life of me who needs to add some CSS to our existing dashboard. So I need to add an explanation to this field view. So I'm going to look for a similar looking thing, and I will inspect element because I have no idea where it lives. And it looks like this particular explanation actually gets its styles from like 3 different places. So I try to grep for the first one because I don't think we have source maps set up properly. And I don't find anything, and that's because it's arbitrarily nested like 3 levels deeper than it should be. And if you look at the side, like there's much more nesting beyond just what the screenshot captures. So at this point, it's probably no longer worth it to try to find the styles I want. So I take the last set of styles, find the color, make my element look as close as possible. And so there's another 8 lines of CSS added to our code base. It's no big deal, right? Unless you're doing it for 3 years and over many different developers who have their own styles of overwriting. But it definitely gets the job done. And after performing this horrible process many times myself, I have determined that there are 4 stages of CSS degradation. And the first one is determination. This is where we are 10 people total at Stripe, right? We are starry-eyed and eager to ship a user dashboard. And we're smart, too, right? So we'll pull the best tools in. We will pull in Sass. We will clearly define how we want to organize our views and CSS in a way that makes styling them really easy. So we ship a thing and we celebrate because we have an MVP. 1 year and 10 engineers later, we are in the development stage. This is where we start building the non-MVP features and enhance existing features. So everything's still good, everything still works. And everything's like semi-easy to find. Maybe you need to look in 2 places instead of 1 to find what you're looking for. And of course, Sass is still super useful, super easy to add new CSS. And there's inevitably going to be bugs introduced as we continue developing. But because I'm just fixing this bug, and it's pretty urgent, and maybe I'll leave a few importance in the code, but it's okay, because I'll fix it later. Like, it's not important that I fix it now. So as Adam mentioned before in his talk, CSS is append only, so keep in mind that this poop will probably never disappear. So another year passed, and another 20 engineers, and we're at 30 engineers now. Development's picking up pace, and this is where we enter the 3rd stage of code degradation, and it's denial. So the dashboard still works most of the time, so everything's good. I can't hear or see any of this poop in the CSS, because I only touch it once or twice per week. And you know, this is even my team's code to maintain. It's not my project, so why do I care about this? And 1 year and 40 engineers later, you're growing exponentially, and so is the poopy CSS. And this is where you enter the 4th stage, despair. This is where every time you fix a bug, something breaks. Your CSS is growing at a rate about 3 poops per week, and there's nothing you can do about it because everything's hopeless. So let's break down how our existing dashboard CSS managed to spiral downhill so badly. It's not that in stage 1 we made the bad decisions. I think the decisions we made at the time were 100% the right decisions and were perfect for our size and our expertise and our timeline for the project. The way that our CSS was handled was optimized for, you know, fast development and simplicity. But as our organization grew, our CSS needed to, our CSS needs started to change. Not every engineer that joined was good at or even cared about CSS. And more importantly, they didn't have the context to know exactly how every view in our CSS or in our code base worked or was used. Regardless, I believe that if we can start over and treat CSS as a first-class tool, we can avoid some of these problems. As an example, we wouldn't write JavaScript without tests or without a linter, right? Maybe. So why would we tolerate such things in our CSS? So what were the problems? First problem, I think, was that there were no tests. And some people say it's almost impossible to test CSS, and that's sort of true, and we'll get into that later. The second was that there were no conventions. Well, technically there were conventions, right, that each template can have an SCSS file in the same folder as a template. But more specific than that, the actual way the CSS was written had no convention. We'd see everything from nested selectors to very vague selectors to, more specifically named selectors in various forms, and some IDs even in there. And finally, what I think was our most important issue was that we had no CSS reuse. Again, technically there was CSS reuse, just not any sort of structured, documented, or explicit kind. Our form of reusing CSS was reusing the CSS that styled our various reusable backbone views. There was no concept of like pulling out a view or CSS that you found useful in other places. So as an example, we have this thing called transfers list view, which you think is only used on the transfers page to display the transfers list, but it's actually used in 3 places. And to display looking at the file and that CSS, you have no idea that that's the case, and you have no idea that it's being used in many different contexts. Meanwhile, sublist subscriptions list view is actually only used in 1 place, even though it seems like something that might be reusable. And there's absolutely no documentation which components you can reuse and which you can't. So why does this matter? The first thing is that too much of this cruft buildup will make it really hard to tackle the non-MVP problems that you eventually want to get to, right? Like mobile readiness, accessibility, and you just can't tackle those things unless you look at every single file and rewrite every single view. And it gets progressively more sluggish or snailish to build new things, and that eventually causes unhappiness while working in the code base. And even worse, like disdain or shame for the code base and the project that you're working on. So let's start over, this time from CSS first. Since we built this iteration of the dashboard over 3 years ago, a lot has changed, and there's more tools available now to solve our problems and allow us to think of CSS as a first-class citizen, just like other tools that we use. Most developers would cringe if they left crappy JavaScript in the code base, and we should think of CSS the same way. So The first problem we should tackle was the last one that I mentioned, no CSS for use. We're tackling this problem with our own CSS component library called Bootstripe. We also considered like stripe strap, but this wasn't as good. We split our dashboard designs into composable components, everything from a responsive content section that can be composed with other components, all the way to the smaller details like big number. And this will format a number into the currency of your choice and for the locale of your choice. And all this documentation is automatically generated, and it's written right in your code, in your CSS file. So it's right in your face, and you feel guilty if you don't update it when you update your CSS. So investing the time to build these components may seem kind of daunting, but once Bootstrap was finished, it was extremely easy to fill a page on a dashboard with these components, and then we can worry about the 10% left that's implementation and polish. And you don't have to worry about these like little things being styled because we probably would have thought about them in designing our more context-specific components. So one side effect was that developers who did not know CSS at Stripe began using Bootstrap for their own projects internally. And this was something that really didn't happen before because it was so difficult to get something to look nice, and many developers don't know CSS at all or are really bad at design. So this allowed them to get something on a page looking nice without having to consult designers or write CSS. So the next problem was no conventions. So here's what we've settled on in terms of class naming. We have a namespace, dash component name, dash descendant, dash dash descriptor. So as an example, we have Bootstripe is our namespace, so BS dash big number dash delimiter dash comma. And a big number delimiter is like the delimiter that delimits your thousands and millions and such. And in this case, it's a comma because we're in the US, but in Europe, you would have a period instead. So before we get too much into that, I'll briefly go over the tools that we've adopted for our new dashboard over Sass. So Sass was really amazing for CSS experts. It makes people's lives much easier, but when most folks who work on your CSS only know how to append to the bottom of the file in really arbitrary ways that somehow magically work because Sass is magic, it's time to try find a new tool that will give them less rope to hang themselves with. Rework is what we ended up choosing. Rework is a plugin for CSS pre-processing. In its default form, it takes the CSS you gives it, parses it into an abstract syntax tree, and compiles it into the exact same thing on the other end. So that's not very interesting, and you don't need to know exactly what it means, but the gist of it is that during this middle phase, when you have your CSS in the form of an AST, you can write small plugins that will manipulate the abstract syntax tree before it's compiled back into the CSS. So in this case, we pulled in the rework deciduousify plugin, which turned this evergreen tree into a deciduous tree. This is super cool because rather than pulling in a monolithic CSS framework for CSS non-experts to use, we're now able to pick and choose specific plugins and tools with limited scope so non-experts don't add things to the CSS that they don't understand. So another tool is Suit CSS, and it's a styling methodology for component-based development. It includes a CSS preprocessor built on top of Rework as well as a style guide. We borrowed heavily from the style guide in creating our own and forked the Suit CSS conformance checkers for ourselves. But we didn't take the CSS preprocessor because we had our own needs. So Rework Stripe Conformance is forked from Rework Suit Conformance and enforces CSS you write follows our predefined rules. Not only does the checker tell you if your CSS doesn't conform, it will not even build the file. As an example, I added big dash number to the big number component, and the build fails, and there's info about like what line number it's on and what exactly the misbehaving selector is. So again, because developers will grumble about being dry, we'll pull in Rework namespace to let us omit that pesky namespace that's in every class. We also pulled in Rework Inherit, a plugin that lets us use very simple, very limited inheritance. So in this example, one common way of styling checkboxes is to hide the input element and then style a like fake label element on top of that input element with your actual checkbox style, and then have a second label element that is the actual label of the checkbox. And in this case, we wrote like this whole thing for a checkbox that falls off the page. But for our radio button, we were just able to inherit those 3 elements, and it works well. So we have bundled these and more into our own CSS preprocessor called KF-CSS. And these are the features available in KF-CSS. It includes everything from rework inherit and rework namespace, which you saw in the slides before, to smaller helpers like rework move media, which simply moves all your media queries to the end of the file, and rework vars, which gives us CSS level 4 compatible variables. So there's nothing too outrageous here, right? Like no nesting, there's no fancy math or any function stuff beyond the simple calc function that we're allowing them. Again, in general, we want to limit the scope of the features that CSS non-experts like myself can use and abuse and create all their terrible CSS with. So you're probably thinking that this is getting pretty out of hand now, right? Like all this accessibility stuff we've thrown in, all these long class names. And this is just for one big number, right? But in reality, you're not really going to be writing that much markup. You should only be writing your markup once and abstracting it away with some template of some sort. And in our case, we're using handlebars, but any templates would work. It's not groundbreaking anyway, but abstracting away components makes dealing with deleting code and upgrading your code much easier. And the final issue is no tests. The truth is, testing CSS is pretty hard. One of the reasons we're able to test CSS now is because we're using CSS components. If you've ever had to visually diff a whole page before, you know that it's often not very effective, right? Like things change all the time, and you don't want to always like play find the difference for every change. The hardest part about testing CSS is actually all the different states that your elements can have and all the different ways that those elements can interact with each other. So we have pulled in rework pseudo classes, which gives us pseudo classes for each of these states, and we are able to compose them in our tests to mock these states. And we pulled in grunt Huxley, which then takes screenshots of our test cases and diffs them. And this way we can also declaratively write tests, right? Like you don't want to tell your Phantom.js to go click on this button and then check what the state is. We're able to like explicitly say these are the states that we care about, and we want to make sure that they stay the same. So Huxley is pretty cool. This is an example of a diff that it found from a 2-pixel vertical line change. Another great thing about checking these files in, ooh, I don't know why it has that. Another great thing about checking these files in is that we are able to use GitHub's tools to, the onion skin tool or the swipe tool to see the difference between images. So, why do we care about this? So, why would you build your own component library from scratch when there's Bootstrap around and it's a lot of work, right? Well, hopefully. Sorry about that. Well, hopefully, with your own component library, you're then able to spend 90% of your time building up this component library, and then every time you add new features to your app, you will then just have to do the last 10% of polishing and building. And then hopefully a few years from now, instead of trying to figure out what exactly this means when trying to style an explanation in our settings view, we'll know exactly what class to add. The hope is that if we think about CSS first, then we will eventually be able to think about CSS much less. So, thank you.